Welcome. My name is Kurt Cagle. I am the managing editor for Data Science Central, part of the Tech Target Network. Um, I talked with Shilpi about a month ago about what was going on here, specifically looking at the role of ethics and specifically talking about AI, data science, and how those essentially are affecting the way that we think about information and about the careers in information. So one of the things that I proposed to her was a talk that I've had for in mind for a little while, talking about the disappearing data scientist, because I believe that this actually gives a bit of a roadmap, admittedly a very, very loose roadmap, of where I think the technology is going and where I think that ethics actually plays as part of that overall process. So can you see my screen?
Yes, just bear with me. Well, bear with me, Kurt. Yes, we can see your screen now. Yeah.
Okay, excellent. All right. So, uh, small background, I have worked in as a developer, as an information architect. Most recently, I've been working to help develop the offerings for data science, machine learning, and kind of the general overall overarching rubric of what we would call artificial intelligence. And unfortunately, I think that when you look at what exactly we think of with data science and data scientists, the question really kind of comes down to, well, what the heck are they? And why are they important to the overall piece? And more to the question, if you are looking at getting into the field, what does that mean? What options do you have, and how does that impact, what you should be thinking about in terms of your career developments, what you should be thinking in terms of the longer issues about how these impact not just technical fields, but even non-technical fields. So, one of the things that I want to point out is that when we talk about data science, it's been around for a while. The notion that data science is this new field is something that I think that there's actually a certain degree of amnesia that occurs the uh, within the programming community and the technical community about what the history is. There are some wonderful, wonderful pieces talking about the nature of information, of data, of programming that extend all the way back into the mid 1950s and early 1960s, when a lot of the capabilities that we had for doing these kinds of processing work were barely even in their infancy. And yet, the need to be able to manipulate data, the need to be able to find patterns and create models has been around for at least that long, if not longer. So, in many cases, when we talk about data science, data scientists have actually been around in a number of different fields. Actuaries, who were people that were responsible for looking at demographic data, trying to determine from that not only insurance information, but also establishing policy based upon the data that they were seeing from surveys, from census data, from other similar types of information. Marketing analysts, statisticians, um, the whole field of sports, for example, has become much more data driven just within the last 15 years or so. But even before then, the level of skill necessary to be able to predict and to determine the future of which sports teams are going to win or which political teams are going to win. What is likely to be the future um, of elections and other things along those lines. Those areas were essentially in the realm of the statistician. Finally, you have analysts, and an analyst is essentially someone who analyzes, as not no big surprise. But at the same time, an analyst is someone who basically is looking at data, looking at the information that they have available to them in tables, in slowly moving into the computer age, where they're essentially trying to determine not only what are the patterns that have been in place, but can we use those patterns to be able to determine the nature of the future in areas such as business, business analysts, technical analysts, the stock analysts, people who are working in research. Most researchers basically need to have some kind of background in analytics and the ability to work with statistics and the ability to work with stochastics to be able to identify how particular populations of people, of animals, of businesses essentially operate. So the notion of a data scientist has actually been around for a long time. However, or more to the point, when we talk about this, even the tools that we have for data science go back for decades. A lot of people have largely forgotten about languages like Fortran, but Fortran was really the first data science language out there. It was a language that was essentially developed for being able to handle not only basic computation, but also to be able to handle additional work that came down to processing, um, analyzing, determining, creating models, and so forth. That created kind of a separate arc away from the realm of business processing. If you look at the evolution of computers and computer programming languages, you find that Fortran largely kind of led itself into areas like SAS, SRSS, statistical packaging. Eventually, you had programs like MATLAB or Mathematica, both of which were essentially designed to let you take the mathematics and the statistical information, or the statistical formulae, and then utilize that to be able to produce and deduce from those models an indication about how accurate information was and how readily it could be used to determine what future actions would take place. So, with that, data scientists themselves, and the term, is not all that old. In fact, if you look around, the first usage of data scientist as a term only goes back to about 2000. And it was a different usage than you had. Data science as a concept has been around forever, but the notion of basically someone that is focused purely on the data science, or purely on the data and data processing, is something that has only recently emerged, really within about 2012, 2010, 2012, or thereabouts. And for a while, it it essentially became kind of a point, or a badge of honor. It was driven largely by the rise of two computer languages, the R language and Python. R was actually kind of an open source evolution of packages like SAS and SRSS, that essentially provided command line utilities to be able to generate data and to perform model generation upon that data. Python originally started as a somewhat generalized language, but by the mid 2010s, it had become, through the use of specific packages like NumPy and suddenly drawing a blank on it, but others along those lines, had increasingly become the language for statistical manipulation. To a significant extent, that is still true. And there is evidence that R has kind of been declining in response to the rise of Python as a language. Now, what I can say from that is, programming languages basically rise and fall all the time. Um, there, if you look at where certain languages are strong, they tend to cluster in specific areas. Python, for instance, has become significant as kind of the tool of choice for working with data analytics, and has also, by dint of the fact that it allows you to do certain additional mathematical processing, has become critical in machine learning, which I'll get into in just a little bit. So in most of these cases, these particular tools then essentially identified the data scientist as someone who was basically an expert in these tools. Now, there's a worthwhile note here because it does determine the nature of the evolution of these particular fields, and it's an ongoing evolution. When you see there's a distinction between a data scientist and a programmer. A data scientist is essentially someone that is creating models to be able to manipulate data, or to analyze and manipulate data, to be more precise. That analysis process differentiates them from being programmers who are essentially building the tools to be able to make these happen. So the tool builders are essentially programmers. The tool users are largely data scientists. That is also changing somewhat as we begin to move increasingly into models where machine learning becomes prevalent. But for a lot of the purposes of distinction about what makes a data scientist, you can readily say that that data scientist is going to be someone that is using statistical based tools to be able to perform the analysis. Now, again, in addition to this, the notion that a data scientist is someone that basically is just a technical expert in these tools is something that is changing as well. So, given that, one of the key things that have evolved really within the last 3 to 4 years, although the foundations of it have been around since, again, the early 1960s, has been the rise of neural networks. And neural networks and machine learning are essentially two areas in which you are seeing the distinction arise between those people who are developing the tool sets, or those people that are basically using statistical analysis to be able to determine behavior, and those people that are essentially attempting to create models, using the models themselves to be able to handle areas such as clustering for identification purposes, or identifying local minima to be able to determine where information, or where you see the most optimal solutions for particular jobs, or in areas where you're dealing with sequential operations such as BERT, which is a natural language processing technology for text, or for speech manipulation, that effectively is a key part of working with any kind of natural language work, NLP work. So those that shift from the statistical to the neural is basically changing the distinction between these two, and you can almost say one is old school data science and the other is new school data science, and they do different things. I don't think there's any real, you can say that neither or that one or the other is actually less important in terms of their overall impact. It's just that in one case, what you're doing is looking at it from a more of a statistical basis, whereas in the other case, you're basically using higher order mathematics and in some cases, even nonlinear mathematics to be able to build the models that determine behavior and from that essentially evolve into the next generation of tools that we're working with. And these are very exciting times. I mean, when you start looking at this, you can basically identify things like image recognition, um, uh, visual recognition or video recognition, which is essentially a key component to things like driving autonomous vehicles. Any type of categorization is increasingly being done through neural networks. Natural language processing and determination of things like chatbots are also being run into that. So, in some respects, the field itself is already fractured into two distinct areas. So, another phenomenon that basically has occurred is that we went from individual people coming in and being hired as data scientists, usually pretty decent salaries, to the development of data science teams. And this is actually, I think, a very interesting and important phenomenon that occurs because if you're looking for a future career in data science, you need to understand that it is increasingly something where the specializations are becoming more important than the overall term. It's kind of like saying in programming, I can call myself a programmer, but in point of fact, I happen to specialize in areas like user interface design or back-end graph data systems. Those specializations are basically what are determining the next generation of of um, of programmers, but they're also determining the next generation of data scientists. Those include areas like data engineers, who are essentially the people that are responsible for taking the information or for gathering the information, for processing it, for cleaning it, for putting it into forms that can then be utilized more effectively. These are not statisticians. These are basically people that are much more interested in data quality, data assurance, data provenance, data governance, but they are also people who are focused primarily on the pipeline of information through a system. Then you have the data analysts. These are the people that we would tend to think of as the model builders. They're the ones that are essentially generating the 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 models that affect how not only um, uh, the raw information comes in and is processed, but also that once they have those models in place, can be utilized to create new information to predict behaviors that in terms that are not just okay, this is a number, but this is actually a program that is in turn driving other processes. So those analysts are increasingly becoming important as people who are building components in overall data-driven organizations. You have visualizers, and visualizers are essentially people that take data, which essentially are just constructs, and make those constructs meaningful to an audience. Visualizers are actually very important simply because we are reaching a stage now where it's very difficult to be able to take a look at the data constructs that we have and make them meaningful to the average person out there. But if you have someone who can basically turn that information into presentation, whether that's as dashboards or as other things like that, that's becoming an increasingly powerful skill. Additionally, you have areas like storyboard artists or storytellers, excuse me, who are responsible for generating interpretations of that data that in turn will drive future business activity or future organizational activity. Um, you have the programmers who are essentially building the tool sets, but they're focused primarily in this region. So anyone that is essentially working on areas like GPT-3, which is the Google's next generation quote unquote AI package for determined language processing. Those are people that are building out the tools, but they are working very closely with data teams to be able to determine what tools to work with. Finally, you are increasingly seeing the business strategist or the AI strategist who is essentially responsible for taking this information and making sure that it works well to further the overall corporate aims or goals that um, the data itself supports. And this is kind of important because if you don't have someone that's basically acting as an orchestrator and acting to be able to say, this is the kind of data that we need, and this is how we need to get it, this is why we need to get it, and this is what we want to do with it, then basically all of the other processes are essentially just wasting time. So you need to have someone who looks at this from a high level and say, why are we doing this? And this is additionally areas where we then get into data governance and data strategists or data ethicists. The notion that we actually have an ethicist as a position is actually one that I find vastly amusing because it means, among other things, that we now can actually employ philosophers to do meaningful work. And I'm going to get a lot of hack from anyone who happens to be a philosophy major on that. But the notion that you have to be able to look at the meaning of data and why you are gathering it, what are you going to use it for, and how do you determine that there is as minimal a bias as possible, is going to become a very key area for organizations moving forward. There has been a lot of work that's been done that, to be quite honest, is shady. Um, when you go out and say, okay, can I use this information to affect social institutions or political institutions? Can I use it to basically change the way that people vote? Or even to suppress the way that people vote. Those are areas where you need to have someone who basically acts as the consciousness of an organization, but also is someone who understands the meaning and purpose and value of that data and why you have to be very careful gathering it. It is different from being someone that's managing privacy, although there's a lot of overlap. The data ethicist is essentially someone who is concerned about the information that is available, but is also concerned about um, available to to different stakeholders, but is also concerned about, is this something that we should be doing? And this is becoming an increasingly important aspect of data science as we move forward. So finally, I think data scientists, as a consequence, are dispersing into the specialists, into subject matter experts, into governors, and into champions. Those roles become very critical. Increasingly, there are very few roles within an organization that do not, in some way or form, get impacted by the utilization of data within those organizations themselves. We are all in becoming data scientists. Finally, to wrap this up, I think that the future that we're looking at, we talk a lot about AI. AI has become the buzzword, but the reality is that AI generally has only been successful in those cases where there is a significant amount of human intervention that is also involved. So increasingly, I am seeing thinkers, um, you know, influencers, and the those that are basically looking at the future, futurists of this particular area of technology, thinking increasingly about AI not as artificial intelligence, but as augmented intelligence. And augmented intelligence basically means that a lot of the issues that we are talking about, a lot of the capabilities that this current wave of technology provides to us give us significantly more ability than we had before. But because we have more ability, we also have more responsibility. Going back to the old Spider-Man ethic, with great power comes great responsibility. Well, that's happening. We are becoming more and more powerful in regard to our utilization of data. And we are becoming more powerful to the extent that when we talk about that utilization, we need to understand that every action that we have will have an impact upon not just ourselves or our organizations, but upon the world. And so when we get into this whole notion about data, about the role of the data scientist and about augmented intelligence and the like, we have to understand that we are now becoming increasingly responsible for the impacts that we are creating, for society, for education, for various disadvantaged groups. All of these come into play for the environment. These are all issues that we need to be able to resolve effectively. So I think I may be running towards the end I'm at the end of my presentation. So
Great presentation, Kurt. And I think you brought up some great points in terms of comparisons of how the role of the data scientist is changing and how they are becoming more from the generalists to the specialized, different areas of specialty. And so, what is your advice in terms of when people are getting into data science, should they first start as a generalist and then get into specialization, or start with the specialization all at once?
I think that in general, it doesn't hurt to gain at least enough of an understanding about the processes of data science and machine learning and other aspects. And I don't even necessarily call it data science anymore. I think we're in the augmented intelligence realm at this point.
Yeah.
But realistically, anyone going into these fields probably needs to have at least enough of an understanding of the various different components, standards, graph theory, machine learning, neural networks, so
Yes.
forth and so on, that make these up, that they can have a more effective ability to make a decision as they move into their career about what they want, because you can't do it all.
Absolutely. Thank you, Kurt. And I want to let
Thank
the
you.
audience know that if you have more questions for Kurt, he is on LinkedIn and we have this live stream there. So tag him and he'll be able to answer any more questions that you have for him. Great points, and take advantage of his experience and wisdom. And he's the managing director of Data Science Central. He's written many books. So obviously he is the big deal here. So thank you,
Okay.
Kurt, for all your time. Take care. Bye-bye.
Take care.